Hi, my name is Farish, and our group is Group 31. Will be presenting about the comprehensive security risk assessment and migration strategy for the student information system. The student information system migration from XAMPP on-premise to AWS represents a very critical security transformation, where the original system presented have severe vulnerabilities such as direct database access without network segmentation, hard-coded administrative credentials in configuration files, unencrypted data transformation, and manual patching processes that left systems exposed to known exploits. This comprehensive migration strategy addresses these vulnerabilities through cloud-native security capabilities, creating a robust defense in-depth architecture that enables secure management of sensitive academic data in cloud environment. First and foremost, we will go into in-depth analysis on why the traditional ZEP web base is very vulnerable. The security assessment of the Xen-based deployment revealed critical vulnerabilities throughout the monolithic architecture, where the MySQL database shared the same network segment as the web server with no segmentation controls, creating a flat network where compromising Apache could lead to database access. Database connection strings were hard-coded directly in PHP configuration files with poor credential management, including default administrative credentials, where admin password username is admin and admin123456, where admin has excessive privileges. User authentication relies solely on username password with no multi-factor authentication option, creating a very significant risk for admin accounts. Not only that, stack-wide vulnerabilities included unmanaged PHP dependencies, version control issues, and manual MySQL patching that left known vulnerabilities unaddressed for extended periods. Backup and recovery processes were entirely manual using MySQL dump without versioning, geographic separation, or recovery testing. Logging and monitoring were minimal, with application logs stored locally without centralized collection or analysis, providing insufficient visibility for incident detection or threat awareness. These systematic vulnerabilities created unacceptable risk exposure for sensitive student data, making it ever more important to commit to comprehensive security transformation for cloud migration. Moving on, we would like to go to in-depth analysis of our AWS architecture that we have proposed and committed to. The AWS architecture redesign employs a defense in-depth strategy through strategic service selection and configuration. Network security forms the foundation with a virtual private cloud, establishing secure perimeters between public subnets containing the application load balancer and NAT gateway, and private subnets that completely isolate application servers and database tier from direct internet exposure. Security groups implement fine-grained traffic control, allowing only necessary communication. LLB accepts HTTP, HTTPS from internet. Application servers communicate with RDS via MySQL on port 3306, and administrative SSH access is restricted to specific IP ranges. You can see that data security leverages comprehensive encryption with relational database service using AES-256 encryption at rest through AWS KMS and TLS 1.2 for database communications. Identity management transforms through IAM roles with least privilege permissions, while managed services reduce attack surfaces through automated RDS patching. AWS WF filtering, CloudFront DDoS protection, and comprehensive monitoring via CloudTrail, CloudWatch, and VPC flow logs, providing robust observability across the entire stack. Thank you.
So let's move on to security migration strategy. So our migration followed a phased security first approach, systematically addressing identified risk. The network isolation began with VPC creation using /36 CIDR block that divided into public and private subnets across two availability zones. The Internet Gateway provided control in external access, while the NAT Gateway enabled outbound Internet access for private subnets without exposing them to ingress traffic. Database security was implemented through RDS provisioning in private subnets with security group MySG1 restricting access to EC2 instance on TCP port 3306, transforming hard-coded credentials to AWS Secrets Manager with automated rotation policies. So the compute layer security deploy EC2 instances using hardened Amazon Linux 2 AMIs with my EC2 role, IAM permission, and encrypted EBS volumes. The migration sequence progressed systematically, starting with VPC provisioning, RDS deployment, data migration via MySQL dump, ARB configuration, EC2 launch, application installation, and DNS redirection to ARB endpoint. Comprehensive monitoring implemented CloudTrail with S3 storage, CloudWatch metrics and alarms, and AWS config rules for continuous compliances validation. Establishing role-based access control with MFA-supported administrative accounts. So we move on to challenges encountered and solutions. So the migration process encountered several significant technical challenges requiring innovative solutions. Database connectivity issues emerged during integration testing and when EC2 instances couldn't connect to RDS endpoints despite correct configuration. Investigation revealed that security group MySG1 referenced IP addresses instead of the EC2 group security group itself. The resolution involved updating security group rules to allow MySQL traffic from the EC2 security group on port 3306 and confirming route table configuration for private subnet traffic through the NAT gateway. The PHP dependency conflicts across rules on Amazon Linux 2, where default repositories contain PHP 7.2 packages, incompatible with the application's PHP 8.0 features. While the web server installed successfully, the application failed post-installation. Resolution required reconfiguring repositories through Amazon Linux Extras to enable PHP 8.0 modules and install required packages such as the PHP CLI, the PHP PDO, and the PDH MySQL IND. So the secret management challenges occurred when the application couldn't authenticate with RDS after credential rotation. The solution involved migrating credentials to AWS Secrets Manager and modifying the dbinfo.inc configuration file to dynamically retrieve credentials at runtime using the Secrets Manager API. The enhanced architecture now includes ECS Fargate for serverless compute, eliminating OS management concerns and providing immutable infrastructures. The AWS CloudFormation enables infrastructures as code with version-controlled, repeatable environmental provisioning. The WAF integration provides specialized protection against SQL injection and cross-site scripting attacks, while automated Lambda-driven backup validation ensures verifiable disaster recovery capabilities, significantly reducing the attack surface and increase the operational resilience. For the conclusion, the cloud migration has fundamentally transformed the students' information systems security posture from a vulnerable on-premise application to a resilient cloud-native solution. The security improvements span every architectural layer, including network micro-segmentation, encrypted storage, identity management, and continuous security monitoring. The elimination of known vulnerabilities through AWS services demonstrate that legacy applications can achieve enterprise-grade security without comprehensive architectural overhaul. Operational challenges with connectivity and dependency resolution provided valuable lessons for both immediate and long-term improvements. This migration established foundational security capabilities that address current threats while providing scalability for evolving security requirements. That is crucial for protecting sensitive student information from persistent external threats. The new architecture exemplifies how strategic cloud adoption with security-first principles and enhance application protection beyond traditional on-premise capabilities without sacrificing functionality or operational efficiency. A successful migration underscores the value of careful architectural planning and service integration, while recognizing that security remains an ongoing commitment rather than a finite achievement in modern application deployments. Thank you.
Hello, my name is Muhammad Daniel and I will show you my demo. So this is our website login page. So our website is they can add new student. For admin, they can add department list. They can add course list, and also they can add user list. So for example, I try to add one course. Yeah, so it shows here. So let's try to do it with the staff page, staff um, staff user. So staff user, they can add department and they can add course and of course they can add user, but they can add student and change the student information. So edit, delete, add academic, update, and print. And they can edit the status of their study. So let me show you my AWS console. So this is my VPC, and this is my um, NAT gateway. Well, let me show you. And this is my okay. It's loading. Okay, so I have user IAM admin and IAM user. So for IAM admin, they have MFA multi-factor authorization. So they need a Google authentication to log in from the AWS using IAM logins. While IAM user, they don't need MFA. So okay, and this is my security group, my SG1. So my security group, they have three inbound rules. I'm using SSH, MySQL Aurora, and HTTP with their own port range fix. And this is my CloudTrail. So as we can see here, we can see what happened in our AWS environment. So as we can see, there's IAM admin. They made a update generated things. So and this is like the root user. Okay, so I will try to my SQL inject. So let's try. Okay. As we can see, my SQL injection is failed, so it passed the test with the SQL injection. Okay, so let me show you my mobile X. All right, so I will show you the my application runs with what VPC with my VPC. Is it wait, not this one. Okay. So yeah, it's true. So we are using the VPC that I show you. So let me try to see the enable the DNS support, and it shows through. That's good. So let's see the table for our security group, and it shows, yep, the port is correct, and port 2 and port 3. Okay. And then, okay, let me fill up the code first. Okay. So, for admin, using password, no. Okay. All right. So this is our um, database that we had in the AWS. So this is academic history, course list, department list, student list, system info, and users. So and okay, so this is um, our port scanning. Okay. So this code, it shows us it tells us if our database in data in database is encrypted, so it shows true, which is good. Let's see our CloudTrail. All right, this is our CloudTrail. Okay, let's see if our database is accessible public. Also, it shows false, which is good because we don't want our database to expose in the public. So I think that's all from me. Thank you.